Good afternoon, class. Thank you. You can sit down. All right, today we are going to continue the presentations on the different formulas for different shapes and figures. And we're going to listen to groups 5, 6, 7, 8, and 9. And if there are formulas that you're not very familiar with, please take some notes, like I said in the previous lesson, because I will not repeat. After we finish today, I'll give you the exercise to do. Okay, so shall we start? Group 5, come to the front. Okay, come you hold one side now. Go to that side. There you go. Up. Sit. Pointer if you need to.
Group 5's shape is trapezium. Trapezium is a four-sided quadratic figure with one pair of sides parallel and the other pair not parallel. When the two sides that are not parallel equal, then the trapezium is an isosceles. The formula for area of a trapezium is area is equal to half times the height, perpendicular height times A plus B. Okay, in the example here we have the A is equals to 14 centimeter, B is equals to 20, and so half, we substituted the length into the formula and we got half times 4, perpendicular height times 14 plus 20. 14 plus 20 is equals to 34. Half of 4 is 2, so 2 times 34 is equals to 68 square centimeter. To find the perimeter, like all quadrilateral shapes, they have to add all the sides, so we found the perimeter of the trapezium by adding all the sides. The perimeter is equals to A plus B plus 2, with those two not parallel sides are equal to 2C. 14 plus 20, so the C is not given, so we have to use Pythagoras theorem to find the angle C. So okay. A squared, C is equals to A squared plus B squared. We subtracted 14 from 20 and got 6 divided by 2 to get those two bottom lengths. And we got 3. 3 squared is 9 plus 4 squared is 16. 16 plus 9 is 25, which is equals to C squared. C squared, the square root of 25 is 5, so we got 5 over here. 34 plus 2 times 5 is equals to 44. So 44 centimeters is equals to the perimeter.
Okay. Thank you, Rita. Okay, this is the perimeter specifically for a trapezium that has these two sides equal, and that is called an isosceles trapezium. Okay, but it usually doesn't happen that way all the time. They are usually not equal. So please take note, it doesn't have to be, you don't have to add this, these two sides don't have to be equal. So depending on the sides, then you calculate the perimeter of the trapezium. All right, thank you, group 5. Group 6. Divide half of the sum of the three sides. It's okay, the way you said it is.
Group 6, our shape is a triangle. A triangle is a geometric figure with 3 straight sides and 3 angles. Okay, the formula for the area, there are 2 formulas. The first one is half times base times height, and the second one is the square root of S side bracket side over side minus A, bracket side minus B, and bracket side minus C, where the side is, S stands for the side, which is the length, you add the three sides and you divide it by 2. And when we substituted the length, so for A is 15, for example, A is 15, B is 12, and C is 9. So when we are use it, it's 18 outside over square root inside. Okay. Area equals square root over 18 times 3 times 6 times 9, which is square root of 2,916. So by using the second area, the answer is, the area of the triangle is 54 square centimeters. Using the first rule is half times 12 times 9, which is the base and the height, and that also equals 54 centimeters. The perimeter, well, there are three triangles: the isosceles, the scalene, and the equilateral. So formula for the equilateral is 3 times S, and the scalene and triangle is add all sides. So we use the formula. Since this is a right triangle, it's also a scalene because the three sides aren't equal. So 15 plus 12 plus 9 equals 36 centimeters.
Wait. Okay, usually when you are using half base times height, that height represents the perpendicular height, not any other height. It doesn't represent a height that is slanted. It must be the perpendicular height. This formula too you can use to find the area of any triangle. It doesn't have to be a right angle triangle, provided the perpendicular height is known. For instance, if you were told to find the area of this triangle, which is not a right angle triangle and the base is 10, but if you were told that the perpendicular height is 5, you can still use half base times height. If the perpendicular height is not known, you cannot use half base times height. If 3 sides are known, like Siegfried has explained, you find the sum of the 3 sides, which is usually referred to as A plus B, A, B, and C. You add them, you divide by 2, and then you use this formula. S represents the sum of the 3 sides divided by 2. And he's actually proven that both formulas give you the same answer. Okay. Well done, group 6. Now group 7.
The group 7 is going to be talking about the cycle. So this is not grade 7, but group 7.
We change positions. Margaret, you go to the other side. Okay.
A cycle is either a closed curve which is everywhere the same distance from a single fixed point, or it is a shape enclosed by that curve. The formula for the area is A equals pi r squared. Circumference, in other words, is the perimeter of the circle. The circumference of a circle is the distance measured around the curve which makes the circle.
To find the area of a circle, we use the formula area equals pi r squared. Pi can be either 3.14 in decimal or 22/7 in fraction. R stands for radius.
Use the pointer. You've got the pointer, so use it there.
Let's look at the example. Say if R equals 3 cm, find A, meaning find the area. Okay, A equals pi r squared. We decided to use 3.14 times 3 squared. 3.14 times 9 gives you 28.26 centimeters squared. However, if you use 22/7, you get the same answer. For the circumference, you either use pi d or 2 pi r. The diameter of a circle is the line that runs through the center of a circle. So radius, 2 radius make up 1 diameter. Okay. For example 2, if r equals 6 cm, find c. C equals 2 pi r. 2 times 3.14 times 6 will give you 37.68 centimeters. If you use pi d, you still come up with the same answer.
Okay, good. Okay, when I was doing my final year at uni, I was required to actually find information how the formula of the circle was derived. And what I did was, I got a circle and I had to cut them. I had to cut the circle in sectors to prove the formula for the circumference of a circle. I had to cut it in sectors. This was my major assignment. I don't know if I passed it, but what I did was I cut the circle into same sectors. They had to be the same and as small as possible. And when I broke it up, I actually lined the sectors. I glued the sectors together, and I actually ended up with something like this. I removed this and then I lined them together and I glued them together, and you actually almost end up with a rectangle. It's almost a rectangle. That's why this the value for pi is an estimated value, because this is not exactly a straight line. But it's almost the same as if you line this and then you found the length, the width of this, and then estimated the length of this, you will actually find that it's almost a rectangle, and the distance will be, the circumference will be almost the same as, because pi is an estimate. You can try that if you want. Okay, next group 8.
We'll be talking about the sector of a circle. A sector of a circle is the shape enclosed between an arc and the 2 radii at the end of that arc. Let's take this circle for an example. Any line that is drawn from the center of the circle to the curve of a circle is called a radius. An arc is any curve of a circle. Radius simply means the plural for radius. To work out the area of a sector of a circle, we use the formula area of sector equals angle of sector at center over 360 multiplied by area of full circle. We multiplied by the area of full circle because a sector is part of the circumference of a circle. It's divided by 360 because a full circle has 360 degrees. The formula is here, area equals pi r square multiplied by area of sector at center divided by 360 degrees. For the perimeter is equals to 2r plus pi r angle of sector at center divided by 180 degrees. We got this formula by multiplying angle at center divided by 360. That's okay. After working this out, we came up with this formula.
Let's look at one example. Let's take the angle at the center to be 150 degrees and the radius to be 21 millimeters. Given that the formula for area is pi multiplied by the radius squared multiplied by the angle of the sector at center over 360 degrees, we have area is equals to pi times the radius squared multiplied by 150 over 360, which is equals to we multiplied the pi by the radius squared multiplied by 150 over 360, and we got the total area for the sector of the circle as 577.5 millimeters squared, because all square units are used for area. Okay, for the perimeter, the formula says 2 multiplied by the radius plus pi multiplied by the radius multiplied by the angle at center over 180. This formula can be also used to find the arc or the length of the arc. So perimeter is equals to
what is it called? Theta. 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 Filipinos probably call it theta, I don't know. I call it theta. Some people call it theta.
So that's 2 times the radius because
given
we have
angle,
2 radius here and we multiply it by 2 plus the length of the arc, which is pi r times the magnitude over 180. We got 42 plus 55, and the perimeter is equals to 97 millimeters. It's more or less like the total length of the whole sector. That's 21, 21. And then you find the length of the arc, which is 55, and that gives a total perimeter of 97.
Good. Well done. All right, group 9.
Our task was to find the area of a shaded region. Area and perimeter of a shaded region. The question reads, find the area and perimeter of the shaded region using the pi be 22/7. To find the perimeter, first of all, we have to find the arc length of the whole sector of the circle, which we labeled A, and the inner arc length, which we labeled B. And you have to add that with the part of the radius, which we labeled J. We have to multiply that by 2 because they are both equal. The formula to times the given angle over 360, which is 2 times 22/7 times 9 times 60 over 360, which gives us 9/3/7 centimeters, or 9.4 to 1 decimal place. Arc length B, we use the same formula, which gives us 2 times 22/7 times 6 times 60 over 360, which is equals to 6 and 2/7 centimeters, or 6.3 centimeters to 1 decimal place. Since we label the part of the radius J, which is also equals to 3, therefore the perimeter of the shaded region A plus B plus 2 times J, which is 9/3/7 centimeters plus 6 and 2/7 centimeters plus 2 times 3. To 1 decimal place.
Okay. To find the area of the shaded region, you firstly have to find the total area of the, let's just say this one, we call it the larger sector, and then this one will be the smaller one. So you find both areas first. Okay, using the formula, area equals pi r squared times the given angle over 360. This is for the larger sector, label A. Okay, 22/7 multiplied by 9 squared, it's the radius there, times 60 over 360. Get 42 and 3/7 square centimeters, or 42.4 centimeters squared to 1 decimal place. Okay, sector B, this one, using the same formula, 22/7 multiplied by 6 squared. 6 squared because we subtracted 3 from 9 to get this 6. Multiplied by 60 on 360, you get 18 and 6/7 square centimeters or 18.9 square centimeters to 1 decimal place. Okay, to get the area of the shaded region, you have to subtract area B from area A being the larger. You get 42 and 3/7 square centimeters minus 18 and 6/7 square centimeters. You get 23 and 4/7 square centimeters, or 23.6 square centimeters to 1 decimal place.
Good. Well done. Okay, well done. Any questions that you may want to ask? All right, this is generally finding the area and perimeter of a shaded region. To find the perimeter of a shaded region, you have to identify the lengths that are around the shaded region, and those are the only lengths that you have to add, just like what they did. To find the area, sometimes you have to find the area of a bigger shape, subtract the area of the one that's not shaded to give you the area of the shaded region. So this one was just generally to find the area and perimeter of a shaded region. Okay, if there is no question, I'm going to ask you to do question or exercise 2 on this. We did exercise 1 already on conversion, A and B. Note the perimeter is the distance. Perimeter was defined by group 1. It's the distance around a shape. So I can see that there is a length which is 12, and then there's 9 and 9 on the other side. So 18 plus half of the circumference of a circle. It's a semicircle. So it will have to be pi. And you are told to use 3.142 for pi. And it will be pi d. I don't have to use 2 pi r. So pi d, and I have to divide it by 2. Or otherwise, if you realize it, then you just have to multiply pi by 6. So we get 30 plus, that's 6. What is 6 times 3.142? 18.852. Okay, so the answer 48.852. Is it centimeters? Okay, 48.852 centimeters. Letter B, any answers? Phone relay.
$29.71 centimeters.
29.71 centimeters. Any challenges? Boromeo? Or you got the same answer? Anyone who has a different answer? Patrick, what's yours? Same. Kyle, do you have the same answer? Okay, let's check it together. Perimeter is equal to 7 plus 7, which is 14. And then there's an arc length again, which is half of the circle. So we are going to use pi d as well. So 3.142 multiplied by 10. So 14 plus 31.42. Sorry, I'm supposed to divide by 2. Okay, which is 14 plus, what's 31.42 divided by 2? 15.71. 1. Okay, so 29.71 centimeters. All right, what you are going to do for homework is this. You are going to complete exercise 1, which has letters C to F. Then 2 and 3. Note for question 3, it says that find the value of x given that the perimeter of the figure is 6.456. It's only asking for the shaded region. Then number 4, 5, 6, 7, number 6, C and D, 7, A, B, C, D, E, and F. Okay? The keyword to the pilot teacher is area. Good afternoon, class. Thank you very much for doing the presentations really, really well. I'm really proud of all of you.